Hello everyone, we're continuing our series on derivatives. Learning how to solve these questions and understanding the reasoning behind them will really help you. I'll try to explain everything in as much detail as I can. Here's what it says. On the coordinate plane, we're given two lines. One is y equals 3x plus 2, and the other is y equals 12 minus x. Along with the positive x-axis and y-axis, these lines form a shaded region, as shown. Now in this region, we're drawing rectangles. One side of the rectangle lies along the x-axis, and each of the top corners touches one of the two lines. So one corner is on the line y equals 3x plus 2, and the other is on the line y equals 12 minus x. We're asked, among all such rectangles, which one has the biggest area, and what is the length of its base along the x-axis? So first we need to make sure we understand what the question is really saying. One side of the rectangle lies on the x-axis, and the top two corners lie on the two lines. For example, it could look like this, or even like this. All of these fit what the question is describing. Now, we're supposed to find the rectangle with the largest area. Let's say we focus on one example. Let's keep this red one and erase the others. Let's call this point here point K. The height of the left side of the rectangle would then be 3K plus 2, right? Which means the opposite side is also 3K plus 2. Now, what's the x-coordinate of the other corner, the one with the red dot? To figure that out, we'll say that this height, 3K plus 2, is equal to 12 minus x. Solving that gives us x equals 10 minus 3K. So that red point over there is at 10 minus 3K. That means the length of the base of the rectangle is 10 minus 4K. All right, now what's the area of this rectangle? It's the height times the base, right? So 3K plus 2 times 10 minus 4K. If we expand that, we get a function like this. And now our goal is to find the maximum value of that expression. To explain this step better, let's draw a graph of that function. We can clear the question for now, we know what we're doing. I've drawn the coordinate axes, and here's what the graph of the function looks like. Can you see it? Since the expression starts with negative 6k squared, the parabola opens downward. That's why we're looking for the highest point, the maximum. If the squared term had been positive, the parabola would open upwards, and we'd be looking for the minimum instead. Now the top of the curve, that blue dot, is what we're after. How do we find that point? It's actually very easy. If you draw a tangent line at the top of the curve, it would be flat, meaning the slope is 0. And if we're talking about slope, we're talking about derivatives. So we take the derivative of our function, and then we set it equal to 0. That tells us where the highest point is. Let's call our function f of k. Its derivative is negative 24k plus 22. Setting that equal to 0 gives us k equals 11 over 12. This is the x-coordinate of the point where the area is maximized. But the question asked us, what is the length of the base of the rectangle, the part along the x-axis? That was 10 minus 4k. Now we just plug in 11 over 12 instead of k, and we find the final answer. It comes out to be 19 over 3. That's it. It was a nice problem, and I tried to explain it as clearly as possible. If you have any questions, feel free to leave a comment. See you in the next lesson.